Assalamualaikum and good morning. My name is Muhammad Ilhan Haris bin Muhammad Hamdi. My metric number is 08DEP21F1076. Okay, so today I will talk about the software-defined network. Okay, so what is software-defined network, or also known as SDN? Okay. Software-defined network or SDN. Okay. Software-defined network is a decoupling of the network control logic from the device performing the function, such as routers, which control the movement of information in the underlying network. This approach simplifies the management of infrastructure, which may be specific to one organization or partitioned to be shared among several. Next. Okay, the introduction for SDN. SDN features controllers that's overlay above the network hardware in the cloud or on-premise, offering policy-based management. Technically speaking, the network, control plane and forwarding plane are separate from the data plane or underlying infrastructure. This will enabling the organization to program network control directly. This differs significantly from traditional data center environment. Okay. Compared in the traditional environment, a router or switch, whether in the cloud or physically in the data center, will only be aware of the status of network device adjacent to it. With SDN, the intelligence is centralized and prolific. It can view and control everything. This is the diagram of the SDN. Here are the SDN basics. In SDN, the software is decoupled from the hardware. SDN moves the control plane that determines where to send traffic to software and leave the data plane that actually forwards the traffic in the hardware. This allows network administrators who use software-defined networking to program and control the entire network via a single pane of glass instead of on a device-by-device basis. Okay, there are three parts to a typical SDN architecture, which may be located in different physical locations. Okay, so this application which communicate resource, requests, or information about the network as a whole. Okay, next is the controllers, which use the information for application to decide how to route a data packet. Next is networking devices, which receive information from the controller about where to move the data. Okay. Physical or virtual networking device actually move the data through the network. In some cases, virtual switches may be embedded in either the software or the hardware. Take over the responsibilities of physical switches and consolidate their function into a single switch. Okay, the switch checks the integrity of both the data packets and the virtual machine destination and move the packets along. Okay, next. The operation of software-defined network, SDN. Okay, firstly, SDN decouples the software from the hardware, much like any other virtualized technology. Okay, SDN keeps the hardware in charge of the data plane, which delivers the traffic, while moving the control plane, which decide where to send it to software. Okay, through the use of software-defined networking, this enables network managers to program and manage the entire network from a single interface rather than device by device. A typical SDN architecture consists of three components, each of which may be situated in separate physical locations. Firstly, application that transmit requests for resources or data about network as a whole. Okay, secondly, controllers choose the best route for a data packet based on the information from application. Thirdly, networking devices which receive information from the controller about where to move the data. physical or virtual networking device transport data across the network. In some cases, virtual switches, which can be embedded in either software or hardware, take over the responsibilities of physical switches and combine the function into a single intelligent switch. The switch validates the data packets and their virtual machine destination before forwarding them. Okay, next. The advantages of SDN. Okay, first, SDN facilitates the movement of data between distributed location, which is critical for cloud applications. Number two, SDN also allow for the rapid movement of workloads across a network. For example, by dividing a virtual network into sections, telecommunication providers can move customer services to less expensive server or even the customer's own server. Next, service provider can use a virtual network infrastructure to move workload from private to public cloud infrastructures as needed, and to instantly launch new customer services. Furthermore, SDN also makes it easier for any network to flag and scale as network administrators add or remove virtual machines, regardless of whether those machines are virtual or physical. Next, the disadvantages of SDN. Firstly, the controller is critical in maintaining a secure network. Secondly, it is centralized and therefore a potential single point of failure. Next, potential vulnerability can be mitigated by implementing controller redundancy on the network with automatic failover. Lastly, the SDN is costly. For the conclusion, SDN technology is a network management approach that enables dynamic, programmatically efficient network configuration to improve network performance and monitoring, making it more similar to cloud computing than traditional network management. SDN is intended to address traditional network static architecture. SDN attempts to centralize network intelligence in a single network component by decoupling network packet forwarding data plane from routing control plane. The control plane is made up of one or more controllers, which are considered the brain of the SDN network and contain all of the intelligence. However, centralization has drawbacks in terms of security, scalability, and elasticity, which is the main issue with SDN. So that's all about the SDN.